We're going to get started. So, prior to today, you guys, you have been learning logarithms, how to take a logarithm expression, make an exponent, take an exponential function, and make it a logarithm. And we've just been dealing primarily with one. Today what we're going to be having is multiple logarithms, like equations and stuff, okay? And we're going to use properties then that help us solve. If you guys can recall, believe it or not, the answer you're getting when you solve for a logarithm is an exponent, okay? So you're actually solving for that, what do you raise something to value, right? It's not so easy to find, is it? It's not easy to say what, if I 3 raised to what power gives me 79. I don't know, but you can take 3, you can raise it to a power, and it can equal 79. You just don't know what that value is. So we're going to be using properties that allow us to find those answers now, okay? Because logarithms and exponents correspond with one another, okay, we can use properties similar to exponents as we do with logarithms, okay? So we're going to refresh our memory on what those are. Okay, so by the time that we've done this, it's like the 3rd time you've seen it this year. Hopefully this will stick. All right, if you have 2 bases and you're multiplying, they're raised to exponents, and you're multiplying them, what's the rule of exponents when you're multiplying 2 bases together? You add them, right? So if I have a base a and it has an exponent of m, and I'm multiplying the base a to an n power, I can just say it's going to be a of m plus n, can't I? Right? And so it's just like a, the base stays there. Oh, it's not? Okay. So an example would be then, if I have 7 to the 5th power and I'm multiplying to 7 to the 2nd power, I could rewrite that as 7 to the 5 plus 2, or 7 to the 7th power. Okay? So that's the rule of exponents when being multiplied. Correct? So the answer, if I take 7 and raise to the 7th power, I'll get the same answer if I would take 7 to the 5th power and multiply it to the answer I got with 7 to the 2nd power. If I have the same base and I'm dividing and I have exponents, okay, what's the rule of thumb on the exponents? What do I do when I'm dividing? Yes, we subtract. So I could rewrite this as a is m minus n. So we're just, the base stays the same, but then I can subtract my exponents. So if, let's say, I have 7 to the 5th and dividing by 7 squared, I could rewrite that as 7 5 minus 2, or 7 to the 3rd power. Okay? And then the last property that we're going to use is the one where it's being raised. So we call this the product, or the power. So if I have a to the m and I'm raising it to the n, okay, what's the rule of exponents when the exponents are being raised to each other? Multiply. So I could rewrite this as a to the m times n. So an example would be if I had 7 to the 5th and that's being squared, I could rewrite this as 7 5 times 2, which would be 7 to the 10th power. Okay, so hopefully these are properties that we're very familiar with because we've been using them all year. But it's kind of refreshing our memory because we're going to do the same type of thing, but when we have the word logarithm, how do we actually use it? Okay, so we have three properties we will use for logarithms. One's called the product property, which is like what we have right here. One's called the quotient property, which is when you divide, which is similar to this one. And one's called the power property, which is similar to when you actually have something raised. Okay, so it'll fall along the same type of lines. Okay, so the product property is, let's say I have log of a base m, and I'm adding a log of base n. So if I have 2 logs I'm being added together, okay, well, in this situation, what was happening? They were being multiplied, weren't they? So I can actually rewrite this then as log of the base and then of the m times the n. Okay, so I can take and make it 1 log then, and then the values that I have here, I can just multiply together. the opposite holds true. If I have one log where there's two things being multiplied, I can separate them and add them as an addition problem. So you can go from the 2 to the 1 or the 1 to the 2. Okay? Alright, then we have what's called the quotient property. And this is, let's say I have log of a base m, and I'm subtracting log of a base n. Okay? So I can, using the quotient property, I can rewrite this. Notice how here they're being divided. So I can take the same concept here and I can write it as 1 log, and then I can divide the 2. So I would be m divided by n. Do you guys have a question?
What's the answer to, I can't read it.
Right here, oh, it's log of the base m times n.
Okay.
Yeah, so log base m times n, like that. Okay? Okay, so then I can take the values of these and I can then divide them. And so now I have 1 log of the base, and then it's m minus n divided by n. Okay? Alright, so now the power property is if I have something raised to it. So let's say I have log of the base m, and that's being raised to an n power. And I can rewrite that then by bringing, notice how they're being multiplied? Well, to make that a multiplication, I need to bring this power down to the front. So I'm actually going to make this an n, and that's going to be multiplied by your log of the base m. Okay, so then this power is going to come down to the front and become like a coefficient to that log. Okay, so these are 3 properties we're going to use going from, this is the expanded version and this is the simplified version. Okay, this is the expanded version, this is the simplified, this is the expanded, and that's the simplified. Okay, so we're going to actually work both to the left to the right, or the right to the left. Kind of see how those work, okay? Alright, so let's give an example. And before we look at what's written here, I'm just going to have you write something here. I'll have you write log of 4 plus log of 5. Okay, so I have 2 logs that are being added together. Okay, so I can use, when I see the addition sign here, I'm going to use the property that would allow me to simplify them. Okay, well, if I look across here, this is the one, the product property has the addition sign, right? So I can take this right here and I can then rewrite this as log, and then you can multiply the 2 values together. So the 4 times the 5. Right, by using the product property. And so then I, in the end, would simplify it to be log then of 20. Okay, and then whatever base you have, you would carry the base. Okay, just it means it can be any base. Okay, so I'm going from it being expanded to then multiplying it to then now it's a simplified version. Okay, over here, they're showing it from the simplified to the expanded. So they're saying log of 20 equals what? Well, you can take 20 and break it out into 4 times 5. And then that would be the same thing as log 5 plus log of 4. Okay? So you can go from the simplified to the expanded, or the expanded to the simplified. Yep?
Does it have to be 1 and 4, or could it be like 2 or 2 and 10?
It doesn't matter.
Okay.
Either one's fine.
Okay.
Yep. Okay. So that is the product. Okay? Alright, so looking at this one, the log base 5 x to the 9th. So if you look at these 3 properties we just talked about, which one of those 3 properties do you think applies?
Power.
Yeah, it's going to be the power property, because I have x to the 9th power. I have something being raised to something. So the power property says take the exponent and pull it to the front. So then I would just rewrite this as 9 log base 5 to the x. Okay, so when you see something like that, you just take the exponent and bring it down, and that's what it's going to be. And then that just is really like 9 times whatever the log base 5 of x is. So whatever this value is, you times it by that, and that would be your answer. Okay? Alright, so that is the power. Alright, so now we have log of base 24 minus log base 2 of 3. So I have the negative sign in the middle, which tells me what property would I be using. The quotient property. So I'm going to use the quotient. Okay? And so the quotient property tells me I'm going to take these two values and I would divide them. So this can become log base 2 of 24, and that's going to be divided by 3. Okay, and just like we do with the exponent property up here, notice how it was the top minus the bottom. So when I have it being minus, it's the first one goes on top and then the second one goes on the bottom. Okay? And so can 24 divided by 3 be reduced at all? Yeah, what can it be reduced to? 8. Okay. Can this be reduced any more? Log base 2, 8. Well, what is that asking me? It's saying 2 raised to what power gives me 8? Do we know what 2 raised to a power that gives me 8? 3. So this actually, the answer becomes 3. So when I look at log base 2, 24, and I'm subtracting log base 2 of 3, it actually equals a value of 3. Okay? So you actually can see how you can work your way down to possibly finding a very simple solution. Okay? So if I would find 2 raised to what power gives me 24, and I subtract 2 raised to what power gives me 3, if I subtract those two answers, I would get 3. Okay? Alright, so then we have this problem here, okay, the log base 3, 5x to the 4. And we have two properties we can use on here. Does anyone see what the two properties? We're going from a simplified, we want to go to expanded now. Does anyone see any properties I could use on this one?
Product and power.
I can use product and I can use power. Okay? I can use product because I have 5 times an x to the 4, so I have two things being multiplied there. And then I have a power because I have x to the 4th. Okay? So when I have this situation, I want to break it apart. So I would rewrite this as log base 3, 5 plus log base 3x to the 4. So first I separate them, right? Because they're being multiplied, I'm going to use the product property. Okay? At that point then, I have log base 3x to the 4, so I can actually expand that one out by bringing the 4 down, can't I? We don't want an exponent, so we want to bring it down. So we rewrite this as log base 3, 5, and then we'd add that to bring the 4 down, 4 log base 3 of x. Okay? And if you don't see that, then this becomes, you can write this as log base 3 of 5 times x to the 4th. And then that shows you have your two items being multiplied, which then brings you to that part right there. Okay? Does that make sense? Okay. So how do we put this into practice? Well, let's look at some examples below. So here I have a situation, and it's telling me it wants to simplify. So I want to go from the expanded to as simple as I can. So I'm going to see what properties I can use to kind of put them together. So I have a log base 4 5x, and it's being added to a log base 4 3x. So I had this plus sign in the middle. So what property makes me put them together? I have product, quotient, or power. Which one has to do with the plus sign? The product. So I want to use the product. So I can rewrite this by using the product as log base 4, and then I would do the 5x multiplied by the 3x. So I just take the values that they're being evaluated to and rewrite it that way. Okay? And now I can just multiply what's inside. So I'm going to get log of 4 is going to be 15x squared. Okay, so this is going from expanded, and it's going to simplify. Okay? Does that make sense? So then that would be your final answer. There's nothing I can do to reduce that one, so that would just be the final answer. Okay? Alright, so on B, okay, does anyone see any property or properties you could use? Okay, quotient, because you see the negative sign right there, right? So we definitely have the quotient. Does anyone see any other property?
Power.
And then the power property, because there's a number in front of a log. When you have a number in front of the log, that is the power property, okay? So we also have the power property. Okay. So my question to you is this. When working with math, there's an order of operation. What comes first, division or exponents? Exponents. So when you have a situation where you have multiple properties, you want to go in the order of exponents, or order of operation. So we want to do the exponent problem first, which is the power property. So how would I take 2 log of base 4, 6, and use the power property? What would I do? I want to simplify it, so what do I do with that 2?
Put it above the 6.
Yeah, we want to put it to the 6. So that 2 got there because we brought it down, so we want to bring it up. So it's going to be log of base 4, 6 squared. Okay, and then go ahead and finish writing the log of base 4 to the 9. Okay? So you want to do the power property first. Okay? Do we know what 6 squared is?
36.
It is 36. So you could just rewrite this as log base 4 36 minus log base 4 of 9. Okay. So then what does the quotient property tell us then?
36 over 9.
Yeah, so it tells us you want to divide the 2. So we'll write this as log base 4 of 36 divided by 9. Okay. Can we reduce that fraction?
4.
Yes. It's log base 4 to the 4, which is 1, right? Nice job seeing that. So now I have log base 4 to 4. Well, what is that property, remember, from last time? Anything with the same base as being evaluated to, this becomes what? 1. So that just equals 1. So then in the end, that's your answer. So what this is saying is, if I take 4 and raise it to whatever value to give me 6, and multiply it by 2, and then subtract out whatever value I need to raise 4 to give me 9, the answer would actually equal 1. Okay? So questions on how I apply those? Alright, flip. Okay, so just like we had expanded, or simplified, we can now expand, right? We can go one way or the other way. So we have here, where it says log base 3, 250 divided by 37. What property would we be able to apply to that one? I have 2 numbers being divided. Which one deals with division? The quotient, okay? And what does the quotient property tell us? How can I take my fraction? What would I do with it? What's the rule of exponents? Subtraction, right? So then I could write this as log of 3, 250, minus log of 3, which is 37. Okay? If you could reduce those, you could go ahead and do so, but we don't really know what those are, so we can just leave it like that for now. Okay? So then you just take the 250 and then subtract. Does everyone see how I did that? Separate them? Okay? Alright, so now we have log base 3, 9 to 5, or x to the 5th power. So, how many properties do you guys see on that one? Can anyone see any properties on this one?
Product.
I see a product. And then what else do you see?
Power.
Power. Okay, so I have 2 items being multiplied together. The property of being multiplication is the product. The power, there's something being raised, that's the power one, right? Okay, so I'm going to rewrite this so we can see this a little bit better. Is log 3, 9, and then I'm going to multiply by x to the 5th. So you see, like, those are the 2 that I have there. right? So you see how I separate them. So that multiplication becomes what symbol then?
Plus.
Plus sign. So I have log of 3, 9, plus log of 3, x to the 5th. Okay, and this is the product right here. Okay, so I'm separating them. And now I'm going to apply the power. So what does the power property tell me? So I have log of 3, 9, plus, I bring the 5 down, 5 log of 3x. Okay, so you see how I separated them out, and then how I brought that down? Alright, at this point, then I want to see if there's any other simplification I can just do in general. Log of base 3 to 9, what does that evaluate to? So basically it's saying log of 3, 9 equals what?
2.
So 3 raised to what power equals 9? And then that's 2. Okay, so this equals 2. So 3 squared gives me 9. So this right here, that equals 2. So then I can just rewrite this whole thing then as 2 plus 5 log base 3 to the x. So then once you get it down to here, you want to see if there's any reduction you can do, any values that you can actually evaluate. That make sense? A little bit? Okay. Alright. Ready to move on? Alright, so now you're kind of seeing how you kind of pull stuff apart, using those properties. So we're going to use those properties to actually find the answers. Okay? So there's times when you may know what values of certain logs are. So if you can use those properties to get them into those values, then you can solve for them. So an example is as follows. Someone is telling me that log base 3 of 5 is 1.465. So if I take 3 and I raise it to the 1.465, that's going to equal 5. Okay? If I take 3 and raise it to 2.7268, that equals 20. So they have given me these values. So I'm going to figure that out for me. Okay? So now I have these other logarithms here that if I can find ways to make them equal the 5 or the 20, I can just use those values instead, and then I can actually solve for it. Okay? So if I look at log base 3 of 100, how can I take 100 and turn it into a 5 or a 20? 5 and or 20. Is there any way I can write 100 by using a 5 and or a 20? 5 times 20 gives me 100, right? So I'm going to take this 100 and I'm going to break it down into log of base 3 of 5 times 20. Okay, does that make sense what I just did? Because I break it down into 2, there's 2 items being multiplied together. What's the property of multiplication?
5.
It's the product, so what can I do with these 2 values? Yeah, I can separate them with a plus sign. So I can actually rewrite these using the product, okay, as log base 3 of 5 plus log base 3 of 20, can't I? Do I know what the log base 3 of 5 is? They've given it to me, haven't they? Well, what is that? That's 1.4650, right? So I'm going to use substitution for that. Do I know what log base 3 of 20 is? Yeah, it's 2.7268. Right? So then what do those 2 values added together equal? They're going to equal approximately 4.1918. So what that is saying to me is if I take 3 because that's a base of 3, and raise it to 4.1918. So 3 to the 4.1918. What do I get? So 3 raised to the 4.1918. I get almost 100, don't I? So you found the exponent that when you raise 3 to it, it equals 100. Isn't that exciting stuff? Alright. So, you have B here, log base 3 of 4. Alright, so you need to find a way to make 4 out of 20 and 5. 20 and or 5. Yeah, 20 divided by 5, right? Okay, so I can take 4 and rewrite it as 20 divided by 5. So I have log base 3 of 20 divided by 5. Okay? So what rule would I use? Quotient. So see if you guys can't see if you can solve this one by using the quotient. So on this one here, you guys, because we decided to make 4 by 20 divided by 5, now I have a quotient going on here. So I'm going to rewrite this part by just doing log base 3 of 20 minus log base 3 of 5. They've given me those values, so I can just substitute it into 2.7268 minus 1.465. When I do the math on that, I get approximately 1.2618. So what that is saying to me is 3 raised to this power should give me 4. Okay, that's what I'm solving for. So log base 3 of 4 equals the 1.2618. You solve for that part. Okay, well, let's check that out. You guys should always be able to check your answer then. So 3 raised to the 1.2618, and that equals approximately 4. Okay, so you see, you get what you're solving for? Does that kind of make a little bit more sense or relationship to what you're doing? Okay, alright, so now we have log base 3 of 125. I need to use 5 and or 20 somehow to make 125. Can anyone come up with a way to make 125 out of one or both of those numbers? I'm going to give you a hint. It's using the property we haven't used yet. So what property have we not used yet? The power. So
5 to the third.
yeah, 5 to the third. Okay, so now 125, I can rewrite this as log 3 of 5 to the third. Okay, so now I want you guys to try and use the power property to get an answer on your own. Go ahead and give it a shot, see what you guys get. In looking at this here, we have where it's a log base, and this is 5 cubed, so something's being raised to a power. So we want to use the power property. Well, the power property tells us to take this exponent and move it down. So I'm going to rewrite this as 3 times log base 3, 5. Okay? And remember, the whole reason why we wanted to use it 5 is because we want to use 5 or 20 because they've given us those values. So now I can substitute. So this right here can be rewritten as the 1.465. That's being multiplied by 3. Okay, it's multiplication. So that can be rewritten as 4.395. So what that is telling me is that 3 raised to the 4.395 equals 125. So let's see if that works. So I have 3, I'm raising it to the 4.395, and it equals approximately 125. So that is correct. Okay? All good? Alright. So that's when they give you the values and how you can substitute them in. You want to find ways of substituting that. Okay? Alright, so now we get to where it's actually called solving. So this is where we want to use our properties to simplify as best as we can. Okay? And then you're going to be left with like somehow to solve for x. Okay? So, looking at example number A. So I have this long equation here. My goal is I want to simplify. I want to try to get all my logs into like one value or something I can use. Okay? So if I see this, what are properties I can use to start simplifying? There's two properties I can use right now. I can use quotient. You see the negative sign, right? The negative sign is quotient. And what's the other one? And a power, because see I have the number in front of the log. That coefficient in front of it tells me it's a power. Okay? So I have a power. Okay? When you simplify, you want to go order of operations. So I'm going to do the power one first. So I'm going to rewrite this as log base 5 x cubed. So the power property tells me to take that and pull it up. Okay, so that's the power. And that's going to be minus log base 5 of 4. And that equals log base 5 of 16. Okay? Now, I have 3 logs here that have the same base. The number one mistake students make is they start crossing out all the logs. You cannot cross out logs if you have more than 2. Okay? If you have an equation where a log is on one side and a log is on the other in the same base, you can cross them out. But when you have an equation where it's something minus or something plus equals something, you cannot just cross it out. You have to continue to simplify. Okay? So do not cross those out yet. Okay? Now, I have something being subtracted, so I'm going to use the quotient. And what does the quotient property say I can do? I can rewrite these terms as log base 5 of what? X cubed over 4, right? I can take the subtraction and I write it as a division. Does that make sense? Okay? And that equals my log base 5, 16. Okay, at this point I have a log on the left side, a log on the right side. They equal each other, so therefore what can I do with the bases now? Okay, now we can do the same base rule. Okay, and I can cross them out. Okay? So now I'm just left with the x cubed over 4, and what does that equal? 16. Alright, so now I just have an equation that just has x. Can I solve for x? Yes. So what would I do? Multiply both sides by 4. So I get x cubed equals 64. How do I get rid of a cubed? Take the cube root, right? So you're going to take the cube root, take the cube root. Alright, what is the cube root of 64? Anyone know? Not 8? It's 4. 4. Okay? So the cube root is 64. So 4 times 4 is 16 times 4 is 64. So that is your answer. Okay? So now you're actually, if you plug in 4 and you put it into these evaluations, the left side would equal the right side. Okay? So again, you're taking multiple logs, and then the one side, you're putting them together. Okay? Alright, let's try B. Alright, looking at B, what rule, when you look at it, can you use? Yeah, the product. I have a plus sign here, right? The plus sign tells me product, so I'm going to use the product. What does the product rule allow me to do? If they're being added together, what can I do? Yeah, we want to multiply them. So I'm going to do log base 4, and that's going to be x times x minus 6, and that will equal 2. Okay? So now, I have a log on the left side and nothing on the right side, so I can convert this into an exponential function, can I? Right? I just put the 4 underneath the 2 and write it as 4 squared, and that's going to equal then the x times the x minus 6. Okay, so we just rewrite as an exponent. So when you just have a log on one side, you can just rewrite it. And that allows you then, the log goes away and allows you to solve for x. Okay? So now I have 16, and that equals, I'm going to multiply this out, x squared minus 6x. Well, now I have a lovely quadratic. We all know how to solve quadratics. So I'm going to put everything in standard form and then see what I got. So I got x squared minus 6x minus 16 equals 0. I just brought the 16 over and then I just put the equation on the left side. Okay, you could factor this one. So negative 16 and negative 6. What are factors of negative 16 that give me negative 6? Yep, negative 8 and 2. Okay? So at that point, I can rewrite this as x minus 8 and x plus 2, that equals 0. So x equals 8 and x equals negative 2. Okay? So at this point, you want to make sure that when you use them up here, none of these values go negative. Well, 8 is fine up here. If I take negative 2, this becomes a negative, so therefore this one does not work. Okay, so you want to make sure, if that's your x value, that none of these logs become negative. If they become negative, it's not a good answer. Okay? And then that would be your answer. So if I take 8 and I plug it in here, the left side would equal 2. Okay? Alright, so you have two examples here. Okay, this one mimics the one above it, and this one mimics the one above that. Give them a shot. See what you guys get. Got it? So let's just kind of go through them real quickly. When I have an equation like this and it wants you to solve it, the goal is to try and simplify as best you possibly can. Okay? Because it allows us to use other properties of logs then to give us an answer. So notice here I have 4 log base 2x. So I want to take that and I want to rewrite that. I'm going to use the power property for that one. So this is going to become log base 2 x to the 4th. Right? I just bring that 4 up to the x. And then I'm subtracting the log base 2 5. And that equals log base 2 125. Okay? Because I'm being subtracted, I'm going to use the quotient rule to combine those logs. I can combine them by rewriting as log base 2 x to the 4th divided by 5. Okay, I just take this value and I divide by that value, and that equals log of base 2 125. By combining these two logs together as one, it allows me then to use the same base property. These can cancel. I have one log equal another log, which means those logs can cancel, and then I just have x to the 4th divided by 5, and that equals 125. Okay? To solve for x, I need to multiply both sides by 5, so it becomes x to the 4th equals 625. I need to take the 4th root of both sides, and the 4th root of 625 is 5, so x equals 5. Okay? Questions on that? Alright, then we get to this other one. So I have 2 logs, they're being added together, so to simplify these, I can use the product property, which allows me to rewrite it as one log with these two things being multiplied together, right? So I can do log of base 8, and that's going to be x times x minus 12, and that equals 2. Okay? So the product property allows me to take this and rewrite it as one log, and then those two values multiplied together. Okay? Because I have one log equal, I can do a rewrite of an exponent. So I can rewrite this as an exponent. So the 8 goes underneath the 2, becomes 8 squared equals the x times the x minus 12. Okay? This is 64 equals x squared minus 12x. Okay, I'm going to throw the 64 to the other side. I get 0 equals x squared minus 12x minus 64. This can be factored. What are factors of 64 that give me 12? 16 and 4. Okay, it's negative 16, positive 4. So I can rewrite these as x minus 16 and x plus 4 equals 0. So I have x equals 16 and x equals negative 4. Now, we've just been accustomed to saying that when x is negative, it's no solution. The one extra step you just have to make sure is that the log is not negative. Not that the answer isn't negative, but the log itself. So if I have negative 4, I got to plug it back in here and see if this becomes negative. Well, x is this negative 4, therefore this doesn't work. Let's say this was like 16 plus x. Well, 16 minus 4 would be a positive 12, therefore that would be okay. So you got to take this answer and plug it in to make sure this part isn't negative. If this part is negative, then that's not an answer. Okay? So this is not an answer, this is an answer. Okay? Does that make sense? Okay. Alright. So we did a lot today.